Binomial expansion, you have to start off knowing what a combination is, and the formula for a combination is NCR. And basically what a combination is basically the number of ways to choose a certain amount of objects from a certain amount of objects. And the equation is n factorial over r factorial times n minus r factorial. And so you have the n and the r right here. And so if you were to say 5 combination 3, you would have 5 factorial over 3 factorial multiplied by 5 minus 3 factorial. And so from that you would get 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 times 1. And so if you start crossing out, you get the answer will be 10. And so that's the basis of binomial expansion. Now the next bit is talking about Pascal's triangle. So you start out with row 0 because this is the first, this is to the 0th power, and that's just 1. And the combination form is that. That's how you write out a combination. So that would be 0 C R, which is 0. And then you go to row 1, which would be 1 0 and then 1 combination 1. And then that is just 1 and 1. And so basically you can go down and go to row 2, which is just 2 0 2 1 and 2 2, and then the pattern continues. And if we transfer over to Pascal's triangle, the way to get the next level is 1 plus 0 is 1 and 1 plus 0. So you gotta imagine there's a 0 here. So 1 plus 0 is 1 and 1 plus 0 is 1. And then you start over. So 1 plus the imaginary 0 is 1. Then 1 plus 1, which is these two numbers, you get like the triangle, which is the concept of Pascal's triangle. You get 2, and then 1 plus 0, which would be 1. And that is row 2. 2, row 1, and row 0. And then to get to row 3, you have to do 1 plus 0, which is 1, 1 plus 2, 3, 1 plus 2, 3, and then 1 plus 0, 1. So the common pattern here is the sides of the triangles, the pattern going down this way and this way. This is always 1. This is always 1, 2, 3. If we continue over, 1, 4, 6, 4, and 1. So as you can see, there's an ongoing pattern.
Pascal triangle, and basically how you start and expand and simplify this is you use the first term and you write here, and then to continue you do a to the power 6, which is given here, and basically you just go down for the rest of it. This is the y or b, whatever you can use, and it counts upwards until you get to 6. So you just keep adding the second term. You just keep going back to the Pascal triangle. See, we're just going down. It's really long and annoying, but you just gotta do this. Halfway there. And then the last one. So you can see for each one, we counted up for y, and then for the x or the a, we counted downwards. So you can kind of just remember that. And for the coefficients, all you do is use this row right here that you got from the Pascal triangle. Alright, now to multiply it out, simplify it even further, it would just be a to the power of 6, and b wouldn't exist, right? And then you just continue. There you go.
Okay, for example number 2, we're going to do a more slightly complex binomial expansion. So the problem that I'm going to show you guys is 2x minus y to the 7th power. So what I like to do, I like to keep things really structured, so I'll go ahead and start making my 8 terms, because it is to the 7th, and when it's the 7th power, they're going to be 8 as the previous equation. So this is your A term, and this is your B term. And your A term always goes in the second part of the term. So you can just go ahead and put 2x in every one of this second parentheses. And now, same goes with negative y, which is your B term. So that goes in the third. And now, for the equations, for the coefficients, you can use either Pascal's triangle, as Azrit showed you guys, or you could use the combination. And for this, I just went ahead and used Pascal's triangle, and the coefficients that I got were 1, 7, 21, 35, 35, 21, 7, and 1. And now we move on to the exponents, and you know, as we go further into the terms, the A term will start decreasing in value. Like for example, this is always 7, this is always this number, and then we move on and it goes 6, 5, 4, 3, 2, 1. And of course the last one is always 0. And so on the other hand, we have the B term that it increases in value, the exponent does. So the first one will always be 0, and then 1, 2, 3, 4, 5, 6, and it always ends at the same power. And if you guys notice, like 7 plus 0 is 7, 6 plus 1 is 7, 5 plus 2 is 7, so all these powers add up to 7, which is the term that we're expanding to. And now all that's left is to do the multiplication and add it all out. So for the first term, if you go 2 to the 7th power and you actually expand everything out, it'll be 128 x to the 7th power. And it would be minus, because negative y to the first power is just negative y, which makes the whole second term negative. So you would get negative 448 x to the 6th. As you see, I wrote down x to the 6th, and y to the 1st. And for the third, you'd get a positive term because negative y squared is positive. So you'd get plus 672 x to the 5, y to the 2. And if you just keep going, everything should be the same process. I'm just gonna keep going. Minus 14x y to the 6 minus y to the 7. And there you guys have it. That's the final expansion. Okay, so for problems like these where you're just asked to find one term, these are short and quick, so they shouldn't be a problem. So what I like to do, I like to write down my rows first, and it should be 8 rows. And since it's to the 5th term, we're going to find the 5th row. And so what comes next is the combination. And to find these coefficients, it's just a regular equation: 7, 0, 7, 1, 7, 2, 7, 3, 7, 4 for the one that we were trying to find. And when you do 7 combination 4 in your calculator, you go to math, probability, it's the 3rd one, scroll over, and 7 before the combination application, and then 4, and hit enter, and it should give you 35. So that's your coefficient for this problem. And then what comes next in the parentheses is your a, and this is your a, and add it, apply it there, and then this is your b function, and that goes there. And what you're doing next, and all that's left basically, is now to find the exponents. And as we know, a decreases while b increases. So for the first term, it would be a to the 7th, because it always starts with the same power, and it decreases by 1 to 6, and then 5, and then 4. And for the one that we're trying to find, 5th term, it would be 3. And then again on the b, this one increases, so it'll start at 0, 1, 2, 3, and for the 5th term it will be 4. So when you add these, combine this term, you should get 2, 2, 6, 8, 0, x to the 3rd.
Okay, and a final type of problem that you can have with binomial expansion is where you have to find a term containing x to the 5th. So what we're going to do for this is we're going to write down our rows. So we have 7 rows because our power is 6. And then our first row is going to be 6 to the 0, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. And then we put down our a values, which is going to be 3x, and then our b value, which is 1. Okay, so we know that the bottom number is going to be our exponent over here, so we can go ahead and put those down. And what it's asking for is x to the 5th. So what we're trying to do is find which exponent will put x to the 5th. So we know that these two have to add up to equal 6. So this is going to be 6, and this is going to be 5. So this is the term that we're looking for. And whenever we solve this through, it's going to be 6 math 3 1, which will give us 6, which is going to be our coefficient. 3 times 3x to the 5th times 1, because 1 to the 1 is 1, which will give us 18x to the 5th. So this is going to be our answer, and it'll be the second term.